Okay, thank you everyone for coming to this talk. Today we have Ben Stock from CISPA Helmholtz Center for Information Security in Germany. Ben currently leads the Security Web Application Group at CISPA, and his research focus on various aspects of web security, with a recent focus on client-side security mechanisms. In particular, CSP and its connection to aspects of usability. His group regularly publishes at major security conferences, such as Usenix Security, CCS, and NDSS. And Ben also serves on the PC and also as track chairs of the venues. Today, Ben's topic is about content security policy, CSP. Learning from its past to improve its future. Now the stage is yours.
All right, thank you very much for the kind introduction. Let me just move things over here. All right, so hello everyone. As already was mentioned, my name is Ben Stock. I'm a faculty at CISPA, recently tenured faculty, so it's very nice to be very much relaxed now in giving such presentations and don't have to worry about evaluations and such in the future. As was already mentioned, my research focus is on client-side web security. And that's also the reason why the topic that I want to talk to you about today, namely content security policy, is one that is of, well, clear importance to me and my research group. And I'm really happy and excited to be here and to discuss some of my group's recent work with you. And I mean that term discussion quite literally. So if throughout the presentation or after you have any questions, feel free to ask those right away. So the talk today will be about content security policy. And in particular, I will highlight actually 3 recent works from my group. But as I said, this is not my work per se, but it's also the work of people that work or worked here, as well as some external collaborators. So in particular, some of the work was led by my former student, Marius Steffens, who was already graduated, now working at Google. And more of the work is then led by my current student still, Sebastian Roth, with collaborations from Katharina Grompot and Lea Gröber from CISPA, as well as a number of other faculty and researchers from other places. And I know for a fact that actually Nikiforakis also visited just this lecture hall, quote unquote, quite recently. So before we talk about the topic itself, namely content security policy, I'd like to kind of discuss something with you, namely, why is CSP such a relevant topic that we should decide to discuss it today? But before we do that, I want to talk about something entirely unrelated. I want to talk about this, knives. Okay, so a knife is something that is very useful, right? You can use it as a tool essentially to carve out food or to carve out art or something like this. But obviously, and I'll put the knife down again, what might happen if you use such a knife is that you cut yourself in the finger. And this is something that can happen to you even though you have used a knife 1,000 times before. But this is not something that you wouldn't know yourself anyways. So the question is, if you use a knife, what is something that you'd like to have around when using the knife? And I guess the answer is a Band-Aid, right? So that if you cut yourself, there is a way to kind of mitigate this problem. Now, I need to apologize to everybody here because I, about a minute ago, lied to you. Because it's not something entirely unrelated. Because I would argue that web development is very similar to using a knife, right? You use a tool to create value, building an application, building some social media system, and so on. But even if you have done that 1,000 times before, you can still make a mistake. And one of the most critical, or even maybe the actual most critical problem that you can build into your web application is cross-site scripting or XSS. And essentially, if you leave your cut finger untreated or you leave an XSS untreated, both of them can have severe consequences because in the XSS case, your users are at risk of being compromised, having their accounts compromised. And essentially, the thing that you want to have around when you use a knife, namely a Band-Aid, you also want to have around when you build a web application, namely a Band-Aid. And CSP, or Content Security Policy, is exactly that Band-Aid, or at least it was designed to be that Band-Aid. However, there has been a lot of work in this area that has repeatedly shown that people do not get their CSPs right. So you kind of have a Band-Aid that essentially doesn't properly stick. And essentially with this motivation in mind, I want to give you a quick outlook of what we will discuss in the next 45 or so minutes. My goal for this presentation is that by the end, you will have seen objective evidence for CSP's failures or the failure of website operators to deploy CSP in practice. But more importantly, have also understood and learned about usability issues of CSP, both from a technical as well as a, let's say, human perspective. And to achieve this, we will first discuss some background and the evolution of CSP, then discuss the struggles of developers in light of third-party content that they have to put on their sites. And then finally, in the last part, highlight important human aspects of CSP development. So first, let's quickly recap cross-site scripting. I'm sure you've all heard this term, but I want everybody to be on the same page here. Cross-site scripting is a code injection vulnerability where an attacker finds that a website, for example, in this case, vuln.com, blindly reflects back this parameter, this get parameter PL. Okay, and so the idea is that the attacker crafts a URL that once this is being visited by somebody, will send a request to the server. There will be a response coming back, which contains this evil script here in this case. Now, obviously, the attacker can try this against themselves, but that's not the interesting part, right? They want to have some victim that they force to visit this URL. And as an example, this could be because they sent them an email or they sent them an instant message, and then the victim kind of clicks that link. So what happens in this case is that the victim's browser makes a request to this vulnerable website, gets a response back, which contains the script source, evil.com. And then the browser doesn't know that this is injected somehow by the attacker or the coming from the URL. So it will diligently do what it's supposed to do. That is, it sees a script that should be loaded. Okay. So that means now the browser will make a request to evil.com, which is under the control of the attacker, download that scripting resource, and then execute it as JavaScript code. And as an example, that could steal passwords or impersonate the user to post something on Twitter, Facebook, etc., and so on. And in light of this threat model, now we can understand what CSP does. So CSP essentially is a server-specified mechanism, which is an allow list of resources that are, when we talk about XSS, allowed to execute JavaScript code. Okay, so the idea is that the developer specifies a list of allowed resources or allowed scripting resources, puts this as an HTTP header into the HTTP response, and then the browser will see, okay, the CSP only allows scripts to come from vuln.com, but not from evil.com, so it will refuse to load the script. That is, it will mitigate the impact of the cross-site scripting vulnerability. And again, thinking about our analogy of the knife, it doesn't stop you from cutting yourself in the finger, but it immediately puts the Band-Aid on so you don't kind of bleed out. And CSP, as such, seems simple enough, right? But actually, CSP has been around, and I recently realized this, that we have 2022, has been around for a total of 10 years. Now, why has it been around for this long, and what has changed over time? I want to go through a tiny sample application here with you to just highlight where CSP has struggled and how the evolution of the standard itself aimed at improving the usability. So let's just have a look at this small example application here, right? So we have some script coming from ad.com, and we know for a fact that the script from ad.com will always include something else from company.com, which is the company that is showing the advertisements to you. And also we have what we call an inline script, so a script tag where we then just have the code that is supposed to be executed in between the opening and closing script elements or script tags. So in 2012, CSP level 1, the way that you would have to configure your CSP to be functional, we'll talk about security in a second, was the following. So we define a script source directive, which controls where scripts can be loaded from. Then we say HTTPS ad.com, and we say https company.com, which would allow this script to be included and then to also include the script from company.com. And then we have this red unsafe inline keyword. And unsafe inline is, as the name suggests, unsafe, because this allows inline scripts to be executed. And the problem with CSP level 1 is that there is no distinction that you can make between an inline script that was put there by the developer, which requires unsafe inline to operate, or a script tag that was injected by the attacker, which, if unsafe inline is active, will also be executed. And this led to the first papers showing actually that nobody was using CSP, and if so, they were using unsafe inline, so essentially in a very unsafe and insecure way. So then in 2014, the CSP standard released version 2. And version 2 adds a nice feature. In particular, it adds so-called nonces. And so the idea of a nonce is that it's a number used just once. So this is supposed to be a random value that the server side generates. And it will attach this nonce to all the inline scripts, as you can see here, that are intended to be there by the developer. And then the developer configures the application such that it sends the header with this nonce. And now what the browser can do, it can, for each inline script, or actually for each script, can check, is it either allowed through the host-based allow list, so add.com or company.com, or does it carry this nonce that was specified in the policy? And since this nonce is supposed to be random and therefore unguessable by an attacker, the attacker can still inject a script tag, but they can never guess the nonce, meaning the script will not be executed. And notably, we can still leave the unsafe inline in here in our policy without having a detrimental effect on security. And that is because CSP is always backwards compatible. So if there is a nonce in a script source and unsafe inline, a browser that understands nonces will ignore unsafe inline, but the older browsers that only supports version 1 will not understand nonces, but will see, okay, unsafe inline, so it will not break functionality. And that was very important from the get-go of this development, that you don't break things for older versions of browsers. Now, level 3 actually addresses a different problem. In particular, here I was just saying add.com will always include company.com, but that's not realistic, right? So today, if you go to some website, the ad company, whatever, double click, will show you ads for BMW. Tomorrow it will be Mercedes, and the day after will be Audi. So as the first party that includes double click to show advertisements, you cannot know upfront which company is going to be the one that you have to allow. And then if you block accidentally a company, you will not get any money because the ads are not being properly loaded. So that's why level 3, which came out in 2016, introduced the idea of what is called strict dynamic. And with strict dynamic, essentially what happens is that any trusted script can programmatically add additional script elements. And let me explain what that means. So here we see the inline script that does create element script source, add.com add.js, and then document body append child script. So this is what we call programmatically added to the document. And you can explicitly trust the script by attaching a nonce to it. And if a nonce script with strict dynamic adds an additional script, it propagates the trust, okay? So that means that if add.com add.js adds bmw.com programmatically, this will also be allowed by the CSP. And this essentially, again, is backwards compatible. So we put strict dynamic in, but we can also leave these host-based allow list entries in. These will be ignored by a modern browser because it says, okay, if there is strict dynamic, we will ignore the host-based allow list. If you have legacy browsers, these will say, I don't understand strict dynamic, but they will still understand add.com and company.com. So just from this very brief history of how CSP, the standard, evolved, you could already see that these changes were always to make it easier to deploy this without breaking your application or without having to massively retrofit your application. If you think about, for example, here, we could also get rid of unsafe inline if we externalize all our scripts, but that's a lot of effort. So now you could say, well, probably this helped, right? So we added these new features, meaning that in most likely scenarios now, CSP should be picking up and people should say, yeah, I can deploy CSP finally. And to actually look at whether this is the case or not, I will take a look together with you into the past. Now you could say, well, how exactly do you go to the past? Because you can't just say, give me like travel back in time 10 years and see how the situation looked like 10 years ago. But it turns out you can, at least virtually. And what I mean with this is you can use the so-called Internet Archive. So that is available under archive.org. And so if you wanted to ever know what Google looked like in 1999, this is actually shown here. And the Internet Archive is nice to show what websites looked like 10 years or 20 years ago, but it also has this nice feature that when they were crawling 20 years ago, they would archive all the HTTP headers that they saw when crawling and store them along with the response, but prefix these headers as X archive oric dash and then content security policy, for example. So this means we can use the Internet Archive to go back in time, have a select set of sites that we want to look at, and then see how these sites were making use of CSP over time and whether usage increased or not. And we actually did just this for a total of 10,000 highly ranked sites, highly ranked over the entire period that we were looking at from 2012 to the end of 2019, essentially. And if we look at this, things are seemingly going upwards, right? So that's always a nice graph if things grow. So what we can see here, the red line is the total adoption of CSP, and we can see that at the end of our experiment, about 10, 11% or so of sites make use of CSP. That's good. What we can also see is if we look at the levels of CSP, and while there is no explicit, let's say, version in the header, we can say that if a policy makes use of nonces, it is at least a level 2 policy. If a policy makes use of strict dynamic, then it's at least a level 3 policy. And what we can see here is that the lowest line essentially is CSP level 1 features being used. So as we said, right, it's not really usable in practice, meaning this is to be expected that the least sites actually use just level 1. And we can also see that level 3 actually is now at the top, kind of overtook level 2 policies towards the end of 2019. So this seems to be great, right? CSP was advanced and was further developed to make it easier to use it. Perfect, right? Things look great. Actually, they don't. And the reason for this is that we also need to look at the use case for CSP. And I only told you about the XSS mitigation use case, but there are also two others, namely framing control and TLS enforcement. And these features were added in, you guessed it, level 2 and level 3 respectively. So out of the policies that are actually flagged as level 2 and 3, most of them are flagged because of TLS enforcement or framing control. So now we can still say, well, still things are going up. So this looks still fine, right? More people are going for script corner restriction. But now we need to understand when they go for script corner restriction, do they do it in a safe way or not? And we already saw unsafe inline earlier in my example, which is a dangerous practice. So if you have that in your policy, it's essentially, unless there are nonces, it's absolutely insecure. And there are some other things. So you can, for example, in a CSP also include something like HTTP star, HTTPS star, which means scripts can be loaded from anywhere. And if that is in a CSP's script source, again, zero protection. The same goes for so-called data URIs, which are somewhat comparable to inline scripts, so with unsafe inline. So again, if that is in a policy, absolutely insecure. Now, if we look at the evolution now, the top line being script content control, we can see that about 90% or so of all policies make use of unsafe inline. And even if we added all of the dangerous practices together, I think we end up at like 95+% of policies that are trivially to bypass because they don't offer any protection whatsoever. So the question then is, why is this happening, right? So why do people deploy a CSP and then not actually get their act together to make it a secure CSP? And to kind of take a little bit of a look into this, I want to discuss one use case. And this use case is Airbnb. So Airbnb obviously is a company that makes most, if not all of its money through its web properties. So to them, having a secure web property is very, very important. Now, Airbnb started with their CSP, let's call it journey, with report only. So you can run CSP in enforcement mode where it blocks scripts, or you can run it in report only mode where it doesn't block anything, it just gathers telemetry. And this is typically the way that you should go when deploying a CSP, namely look at telemetry of your users and then figure out if the policy might be too restrictive. And so they started end of 2014 with a report-only policy with script source already containing 17 different hosts. Then they went to add HTTPS, so essentially have no protection whatsoever in March 2015. Then switched to enforcement mode just 2 months later, but still had in their script source HTTPS. And then over the next 2.5 years, they made a total of 222 changes going back and forth and trying different things, ending up with a script source with 32 entries, still including HTTPS. Then in January of 2018, they tried to harden the CSP by removing HTTPS, and they did this for exactly 1 single day. Then they went back to essentially adding HTTPS in enforcement mode because apparently stuff broke on their website. And then finally in March 2018, they managed to get a CSP that is secure by the definition of not trivially bypassable. So it's not really said that this is secure, it's just not obviously bypassable. So it took a company whose main business is the web presence 3.5 years to deploy a CSP that is not trivially bypassable. And that just shows you that even with significant engineering effort and security being paramount to such a company, it's incredibly tough to deploy a CSP. So to just take away from this first paper, which we published at NDSS 2020, most CSPs do not effectively mitigate XSS. And I didn't even go into showing you how many people tried to deploy a CSP and then gave up, which is actually quite a lot. And I encourage you to read the paper on this. And secondly, even if you are a major company, you will take ages to deploy a CSP, and it's a massive engineering effort. So now from this, we could deduce, well, but there are developers, and these developers, they need to maybe change their code and so on. But given that 95% of the policies in the world are meaningless against XSS, developers must be to blame, right? They just can't get their act together and don't spend enough time on fixing this goddamn problem. But this is maybe too easy. So for NDSS 2021, we asked ourselves, whose behavior is it actually that interferes with CSP or a secure CSP? And there are actually 2 big problems that we can face when we want to deploy a CSP. The first one being that we somehow require unsafe inline, either because of the inline scripts, as we saw before, or what is even worse, so-called inline event handlers. So you have this on some HTML elements, an on-click or on-load element defined in HTML. And these can only be allowed through unsafe inline, not even through nonces. So that's one problem. And the other problem is the one that I alluded to earlier that is seemingly fixed by a strict dynamic, namely that you have constantly new hosts being added to your application by, in particular, third parties. So what we did is we ran a 12-week experiment on the Trunco top 10,000 websites, out of which actually only 8,000 or so load and have JavaScript. And we collect the inclusion, so which code is including which code from somewhere else, and what is the behavior of the first party versus third-party code. And now for problem number 1, for unsafe inline, right, there are things that mandate the use of unsafe inline. We can nonce or also hash inline script, so we can also compute the hash of this inline script and put that into the policy. But for event handlers like this on-click do something, we cannot, as a first party, have a CSP that is safe, yet leaves this on-click handler functional. And so what we looked at then is which are the parties that mandate the usage of unsafe inline because they either have inline event handlers or inline scripts. And I don't want to go over the entire table, but what I do want to point out, again, we had about 8,000 sites that we even only considered. Out of those, on 6,000, there is at least one third party that mandates based on how they, for example, use document write to add additional scripts, inline scripts, or event handlers, and so on to the document. 6,000 block the first party from using a CSP that is not trivially bypassable. And the vast majority of them actually is using event handlers. So even if somehow these third parties said, yeah, we can use a nonce, or the developer said, I can pre-compute the hash of this inline script being written by the third party, they cannot do anything against inline event handlers. So 3 out of 4 websites will be blocked by a third party from deploying a CSP. And importantly, it's not just 3 out of 4 that are blocked by just one party, right? Where you just say, okay, I don't use DoubleClick anymore, but some other ad company. It's actually worse. And there are multiple sites, actually, again, about 3/4 of the sites that are blocked, for which there are multiple third parties to blame. And one negative example, at least back then, I don't know the current state of affairs, is Twitter. So Twitter has a policy that is actually safe. So if you go to twitter.com, look at the CSP, this is a safe CSP. But the widget that you need to include into your own website to have, like, I think it's like retweet button or something, or follow me button, I don't know which one it was. That one actually causes or uses, as far as I remember, event handlers, inline event handlers, meaning they will block other people that include the widget from deploying a CSP on these first-party websites, which is a big problem. Now, the second problem is this idea of rotating hosts, right? So that is, you have today BMW, tomorrow Audi, and so on and so forth. And I don't want to go through the entire graph here for the entire week, but for the entire weeks. Importantly, 5,400 of the 8,000 sites add content from at least one previously unseen ELTD+1 in this 12-week window, and 3,000 of those through third-party scripts. So that is, again, about, let's say, 40% or so of the pages that make use of JavaScript have at least one third party that will, in a 12-week period, add something that comes from an entirely different site. And that means you have to update your first-party CSP to not cause breakage. Now you could say, well, I remember from earlier, he said something about strict dynamic, right? And strict dynamic can solve this problem. So we asked ourselves then, can we just say, use strict dynamic and be done with it? And it turns out that most third parties will programmatically add new scripts. So that's great. And only 1,100 of these sites in our data set have an incompatible third party that adds a script through saying document write, script source, something. Perfect, right? Strict dynamic, and we're done. Turns out this is not the case. Because strict dynamic, we can only use if we have nonces or hashes, because that's the only way we can explicitly give out the trust to the first script in this chain. But if you remember what I said earlier about the presence of unsafe inline and nonces, then unsafe inline is ignored. So if we are required to use unsafe inline because of, for example, inline event handlers, then we cannot make use of strict dynamic. So it turns out that only 1,800 sites have third parties that fulfill both criteria, so that they both add only programmatically new scripts and that they don't require unsafe inline, meaning that 76% of all the websites in our test set will be blocked from using strict dynamic by their third parties. So that kind of shows that it's not easy to just say, first-party developer, get your act together and you're done, but this needs to be seen in a bigger context of the third-party ecosystem that is the web today. Now, after this rather, let's say, objective part where we can just measure things and then tell you about the results, let's now switch over to the more subjective part, namely the human perspective on content security policy. And this is work led by my student Sebastian, which was published last year at CCS, which is called 12 Angry Developers. Coincidentally, we had 12 developers in our interview study. And our goal was to investigate the human aspects of CSP deployment, so actually go into subjectively understanding what's going on. And we had a number of research questions that I want to go through with you in this talk. The first one being, what are the motivations for people to even deploy a CSP? The second one, what are their perceived roadblocks? We already saw some technical issues with on the previous part. What strategies do developers adopt when creating a CSP? So how do they change their code and so on? And finally, what I will not discuss in too much detail now, how well do developers actually understand the associated threat model of CSP that I showed you in the very beginning? And in order to answer these questions, we conducted a semi-structured interview, which included a drawing and a coding task. And I will talk about the code or the task in a second. We then transcribed that interview, used an open coding process with 2 coders, and eventually then this allowed us to find these motivations, strategies, and common roadblocks. And we could finish at 12 people because I think after 9 of the developers' surveys or interviews, there were no new themes being added to our coding process or our codebook. So what was this coding task about? So we intentionally built this coding task to cause problems with CSP, right? Because we have already knowledge about what will be a problem when deploying a CSP. So as you can see here in the example, we have on-click handlers, which you cannot get rid of unless you, so you have to get rid of to not require unsafe inline. And we just have regular inline scripts as well, which need to be nonced or hashed. And we didn't do this to just annoy people, but we in particular did this to figure out what are their problem-solving strategies, and can they maybe recall certain problems that they had faced themselves that they didn't note beforehand in the interview when we asked them about their struggles in practice. And with this, let's now talk about first the motivations. And there are essentially two big groups of motivations that people told us about. The first one being rather threat model or attack driven. So most people said CSP is used against XSS or as an XSS mitigation. Less often, they told us about that they know about framing control and TLS enforcement. This is also something we had seen in some previous studies. Importantly and interestingly, there's also often an external motivation. And this goes from a pen testing or a consulting company telling them you should deploy a CSP to being actually like using CSP as a defense in-depth mechanism, what it's supposed to do, all the way to actually saying we serve as a role model for what a secure website should look like. So that's why we have to have a CSP. And this I found very interesting. But at the same time, most people actually said there was some external motivation for them, like a pen test or a consulting firm that said, you should deploy some CSP. Now, looking at roadblocks, there are actually a couple of intertwined problems here. So first, we have the developer. CSP is a rather complex mechanism. I only showed you a teeny tiny part of it all. And there are actually like 16 to 20 different directives, and you need to understand how these interplay, what fallback rules are, and so on. Often people also had some knowledge gaps about, for example, strict dynamic, or even conceptual issues where one of the interviewees told us that CSP was somehow enforced by the server because it's a server-side deployed mechanism, which is clearly wrong. And part of this problem is that you often have information sources which fail to give you the bigger picture or mislead in claims. And I want to give you an example here of a question that is coming from Stack Overflow. And we all know Stack Overflow typically values utility or usability over security. So the question here is essentially about, well, CSP blocking inline execution. He says something here, this developer says, I'm using an external payment company, right, third party, and it's being blocked. And now the obvious very short answer is this one. Have you tried adding the unsafe inline keyword in the response header instead? It goes on to say, but you can also add the hash of the script. But probably the developer said, oh, unsafe inline, I'll use that. And it works. It does not mean you have a secure CSP anymore, but it works. Then from an application point of view, you often have a lot of legacy and old code, right? You need to rewrite your inline scripts, externalize them, and so on. And I found a really good creative solution to this problem of rewriting inline scripts to add nonces to them, because nonces mean you need to somehow keep the nonce in the header, but also have it in every HTML document. So how do you best do that? And the answer is in this GitHub issue. Feature request static nonce for script and style text to avoid unsafe inline CSP header field. So as you probably can imagine, it is not really different from a security point of view, whether you have unsafe inline or a static nonce, because the attacker can then just use the static nonce when injecting a script. But it does get rid of this unsafe inline keyword. And if you just have some external tool that checks your CSP, it will tell you, perfect, your CSP does not have unsafe inline, it has nonces, great, you're safe. Obviously, again, missing the bigger picture here. Then another problem that the interviewees told us about is that they are not working in isolation. So you are working inside a company. So that is, you have different development teams and financial consequences and decisions that are not taken by you as the security engineer, but rather by somebody else. And there's this one quote here, which was talking about the marketing department, essentially saying the marketing department wanted to run some quick thing, pick up some hype at the moment, and they just installed some stuff such that the that this thing works. But the CSP broke all of this. So then we essentially said, the developer said, so the policy made the site unusable, so we made it usable again. Again, functionality much over security. We already alluded to third parties as a problem earlier, so I will skip over that. But even if you get all of this right, okay, so you have the marketing department under control, you understand the bigger picture, get rid of all your inline scripts and so on, you still end up with users. And users do not all have the same browsing engine. And one of the problems is that actually there is just recently Safari in version 15.4 came out with a fix to support strict dynamic finally, after 6 years or 5 years since it was proposed. But before that, if you had Safari users, which everybody has, you couldn't use strict dynamic. Similarly, you have inconsistent console messages. So it depends a lot on who is the developer of this site. Are they properly supported in getting their information? So for example, here, right, this is in Firefox. It just says the page's settings block the loading of a resource at inline, default source. Whereas Chrome actually talks about default source none. You can either add the unsafe inline keyword. Again, think about, is this a good idea? Probably not that you start with the unsafe inline. And there are many more examples like this in inconsistent browser support. Now, even if all of this worked fine and all the browsers were consistent in how they treat CSP, you probably have in your browser installed some browser extensions. I have one for my password manager, for an ad blocker, or something else entirely. So if you have all these users with all these different browsers, where some of the extensions that might be running in these browsers are injecting content into pages that are being visited, right? Whatever buttons to click to buy on Amazon or something like this. They all visit the same application. And if the CSP is configured in a way that violations are reported, this also means that the telemetry that you get from the field is often just wrong, right? Because it's not a problem of the CSP, but it's a problem of the browser extensions or antivirus engine that inject something into the page. And one of the participants actually said that there was a case where somebody misconfigured a CSP. So that is for every single page load, every visitor would trigger about 100 warnings, which all went to the site. So they essentially accidentally ran a massively distributed denial of service attack against themselves by having all their visitors report back 100 times for each page load. So with these roadblocks in mind, let's now look at the strategies of how people try to solve the problems. When talking about the initial CSP setup, we actually saw two schools of thought. The first one was strict to lax. So you try to have a restrictive CSP early on, and then go further and further and relax it to a point where it's still safe, but functional. The other school of thought is that you go from a very lax CSP to a more strict one, which is often tool supported from the get-go. So you use some existing tool to pre-generate a CSP and then try to work with this. And the latter case is also what we saw quite a lot in our archive analysis, where people really try to not change their website too much, but rather say we try to adjust the CSP to the website. But those, again, in 95% of all cases, will end up with a very insecure CSP. Then when we look at how people deploy CSP, most of them actually try to use one global CSP for all the pages, which means that on many pages you have maybe things that wouldn't necessarily have to be there for the CSP to not break anything, while on others you might actually, because it is changed more frequently, you need to update the entire CSP for the page. And only very few people use CSPs, different CSPs per page. And I think nobody actually mentioned the fact that you can just combine two CSPs and then they will both be enforced. So you can have a global one and then a more restrictive one per page. They also all told us that it's extremely important to regularly reevaluate and field test new policies because websites are changing so frequently, and in particular third parties are changing so frequently. And if push comes to shove, they would always pick functionality over security, which again is not a big surprise in this ecosystem. And then finally, looking at the problem solving strategies, the majority of people try to get rid of their inline code by just putting this into external files and then just loading these external files. Fewer use nonces or hashes, and then even fewer they are used unsafe inline as a fallback mechanism. Getting rid of inline events again, majority of people said, yeah, we rewrite the code, we change the functionality to make it external in an external script. Very few people knew about the unsafe hashes directive, which is also rather new and again, not universally supported. And still quite a number of those participants said, yeah, we use unsafe-inline, which again, functionality over security. And then in terms of third-party code, there essentially people said, well, we try to self-host third-party code, but this doesn't help you in the ad ecosystem, right? You cannot just self-host the double-click code because it changes every day, and then you don't all of a sudden make money anymore because you're not loading the right content. But what I found very interesting is that nobody actually mentioned that you can use strict dynamic to properly integrate third-party code if that behaves correctly, as we discussed in the second part of the presentation. So now we could just say, okay, this kind of sucks and everything is horrible. I'm done with it, right? So for me, I can say I'm tenured now. I'm done with this line of research. But actually, I'm not, because I want to try and understand how we can improve this process. So I want to take the last couple of minutes now to talk about the future or how we can improve CSP and where maybe also the interesting and important research questions are. History has shown very objectively as well as subjectively from our 12 Angry Developers paper. CSP for XSS mitigation is very complex to deploy, if not too complex to deploy. And this even goes to some developers saying, we tried CSP, it's a complex beast, we're not going to touch it ever again. One of the reasons is that websites do not operate in isolation in their first-party code, but also they have third parties which make their life much harder by rotating inclusions, by having incompatible inline scripts or event handlers, and so on. So both of them together mean that CSP has this bad reputation of being too complex to deploy in practice. That actually also means that the good parts of CSP, because we can use framing control and TLS enforcement in isolation, are often ignored, or people say, no, we cannot use CSP, we'll break our website, without understanding the bigger picture that there are three distinct and separate use cases you can deploy CSP for. You can combine them, but you don't have to. So the question then is, how can we address CSP's failures? First, we need to have better support for developers. And this is in the theme of, let's say, left shifting security. Maybe we need to have IDEs where if a developer starts typing an event handler, the IDE will immediately tell him, stop, because if you do this, your page will be incompatible with CSP. The same applies for you start typing script source doubleclick.com or doubleclick.net. And then maybe the IDE knows, okay, we know that this script uses document write to add inline scripts. This will be incompatible with CSP again. So really take this, let's say, knowledge that the community or the research community has gathered about insecure or bad practices and just put that to the developer as early as is possible. A second approach could be to evaluate incentives. So maybe we go ahead and say, you can only use this cool new API that was added to the browsers if your website is deploying a sane CSP, for some definition of sane. One of the problems is that this might be causing blockage because you have a third party that doesn't play by the rules, and then you as a first party are not able to use the fancy new API. The question then is, okay, do you then put pressure on your third party? Do you change to a different third party? Are there even third parties you can change to in this ecosystem, be it ads or maps or something like this? So this essentially also needs to be evaluated, whether it makes sense to try with incentives. All right, so now let me finish up with some key takeaways. First, CSP fails in practice for content restriction. The perceived complexity is extremely high. People are afraid of breaking their websites, and third parties are a major roadblock to the success of deploying a CSP. However, I would argue that CSP can stop the bleeding, if you want to take the analogy again from the beginning of the presentation. If the third parties start playing by the rules, or there's maybe some enforcement even of maybe browser vendors say, well, DoubleClick cannot be loaded anymore unless they get their act together. This is one critical aspect. The second critical aspect is that we need to better support developers from the get-go. Now, this comes with a set of open problems. So how do we best do this to developers? Because if we, every time they type a script tag, immediately give them a warning, you will all know what is going to happen very quickly. They will look for the button in the settings menu where you can turn off these warnings. Warning fatigue. We saw this for HTTPS warnings. We see the same probably then for something like this. So that's a key question. How do we best integrate mechanisms that provide meaningful feedback at a very early stage? Or maybe even taking 1, 2, 3 steps back. How can we maybe redesign the entire mechanism so that developers understand it better and can use it better? Or we have maybe some type of isolation on the web that would allow the third parties to run in their little sandbox, but still be able to do what they need to, right? In terms of advertising, for example, while making sure that their insecurity does not affect the first party. And so that's it from my side. I'm very much looking forward to your questions and discussion items.
Thank you very much, Ben. Now, if you have questions, you can ask by raising your hand or typing in the chat. Right. So let me ask the first question. Right. We can see, right, the main problem here is really the incentives for the developer is not enough, right? Because the third-party company probably pay the developer or the web server or web company, right, to use this script, right? If you block it, you lose money, right? But if this script is malicious and then the user's password gets stolen, then it's not the developer or the web company's problem, it's the user's problem, right? So to some degree, it's really, I don't really have much incentive to care about the other people, right? That's maybe a main problem here.
Mm-hmm. So that's a very interesting point. Thank you for the question. If we look back 10 years today and you browse the web, you expect HTTP to work, right? You go to some website, HTTP is everywhere. And the argument 10 years ago was that the coffee shop website from next door doesn't need to have HTTPS, it costs money, and why would they do this, right? Connection security is only critical for banking applications or something like this. But there was a change in mindset that now you don't have the green lock indicator as in good security because you have HTTPS, but rather you go to having a red broken lock indicator if it's not secure. It's the security needs to be the default, right? So one potential option could be to say, well, if developers don't by themselves understand the risk that they are putting their users up to by not having a CSP and by maybe having a cross-site scripting vulnerability, maybe we should kind of force the hand a little bit and say, yeah, maybe the default is that every browser enforces a sane CSP, some basic CSP that blocks everything or that blocks just everything that's not coming from the first party. And so developers need to understand exactly, okay, why is this there? So why do we have the security mechanism that is in place? What is cross-site scripting even, right? Which I think a lot of people don't even know about. What might be the implication of the danger there? And then they will have the incentive to understand the threat model, to find a potential solution, or then to essentially get their application to be compliant with this mechanism that is CSP. So I think that's where the mindset just needs to be a different one. We need to maybe stop thinking about all websites are fine without CSP and it's just the top few that need a CSP, and move to maybe everybody should have it to have their users protected from the threats of cross-site scripting and such, and then have this change in mindset as we had for HTTPS essentially.
Yeah, that's true. That's true. But on the other hand, can we change the mindset to like, since it's the user's problem, can the user do something protecting themselves, like using a blocker, right? Like ad block. I often use to block the advertisements. Can they use something like browser extension or other things to block unsafe scripts from their side?
So essentially, yes, you could, for example, have something very similar to an ad blocker. where you just block all these scripts. So if there's then a vulnerability coming from some third-party script, then this will not affect you. Or you can even go and try to have some tools that kind of learn a CSP for just the first-party content and then just apply that, right? But the point is, if we went to this where the users would selectively remove things, and we see this in ad blockers, right? So there's an arms race between the ad blockers and the ad blocker blockers and the ad blocker blockers and so on. And it goes back and forth because the website operators, they have an incentive to bypass the ad blocker. And maybe that's a good idea to say, well, maybe users start blocking insecure stuff on websites, or the browsers do it for the users, because the average user will not understand the problem space. And then there will be an incentive for the first-party developers to say, okay, we need to understand how we can get to a point where we do have like our advertisements being rendered or our map services being rendered, so we don't end up losing money, essentially. And I think that's the key point in incentives, right? So if it costs you money, you will do it. And this is, I think, a general theme in security. Security at first costs something. And if you don't spend that money, the breach will cost you much more. Yeah. But the understanding that you need to spend a little to avoid spending a lot later on, I think that's what we need to also see here in this aspect.
Yeah. Okay. Yeah. Thank you. Right. Sia, do you want to ask a question?
Yeah, maybe I can. Here, you mentioned helping developers and providing incentives. Can you comment on the role of changing script execution security policy and also CSP itself to make it hard to use incorrectly? It's a very good point. So one of the let's call it positively features of CSP is that we have these unsafe something keywords. We have unsafe inline, which reallows inline scripts. We have unsafe eval, which I didn't really talk about, which allows using the eval construct. And we have now unsafe hashes, which allows you to hash event handlers, which comes again with some certain risks. Now, the question is, if we design a security mechanism, do we really want to have unsafe fallback options? Because the incentive for people looking at, again, the example from Stack Overflow is great. It doesn't work, but there is this keyword that I can add, and then it will work. And I think if somebody, as I said earlier, right, the motivation for people to deploy CSP often is externalized. So there is some pen testing company that tells you, you should have a CSP because you don't have one. So the poor developer will be told by his boss, you need to deploy a CSP. And then they will do exactly that and deploy a CSP. So anybody who can look at my CV can figure out where I briefly worked as a master student at what company. And so this company has had a CSP for, I guess, 10 years. And the CSP has been insecure from day one, but they still do regular updates. And I can literally see in front of my eyes this discussion between the supervisor that says, your key performance indicators for this quarter are need to deploy a CSP. And the other person says, yes, I deployed a CSP. And if we have this mechanism that you can deploy that is full of holes, then there's literally no point in deploying it at all. And if we don't have this fallback option of going for the unsafe something directives, then maybe less sites would deploy CSP. But again, what is the point of deploying a security mechanism that adds zero protection against XSS? So maybe we should redesign the mechanism, which I was saying about earlier, right? To have secure by default and making it hard to impossible to deploy the mechanism, but in an insecure way. Yeah, thank you very much for the great question.